Okay, you're just going to write your ratio. There's not much cleanup for factoring. We could try and factor the 7, but it's not going to reduce anything for the denominator. So where you're just writing them, you're just kind of making sure you understand the division is a fraction. So I'm just going to make kind of a large fraction bar. So the g function is 3x squared plus 5. The f function is your denominator, so 2x squared minus x. I mean, this is kind of it. We're not in rational functions yet, but I mean, if you wanted to break it up, you see that there's an x term in common that you could factor out. So I mean, yeah, like ideal, you know, if you were taking your SATs and they wanted you to factor them out, or say find zeros if you're in pre-cal. If you're in pre-cal, like you're gonna deal a lot with asymptotes. Which are your restrictions, which we're going to talk about in here with domain, restrictions, all of that, but it kind of gets bled into the functions we're learning about. So that's it. Okay, either one. You could just give me the one on the left. You don't have to factor because we haven't really reviewed it in here. Okay, h of g, I'm not h. H divided by g of x, not of, I started talking about composites. You just make a big fraction, so you just write it. And then g, and again, you could just leave it as this. I mean, yes, you can kind of take out a negative. Right, and if you wanted, what two numbers multiply? 3, right? Oh, but no, we can't factor it. You know how what two numbers multiply to 3 but add up to -2? The problem is 3 times 1 is 1 times 3, right? But I need -2, so I would need one of these to be negative, so yeah, it doesn't work. So yeah, you could just give me the left. You don't have to take the right. Fair? Yeah? Okay, 8, you have a multiplication. It's not a bubble. So typically when I'm writing stuff out for you with quizzes, I will do this notation with the double parentheses. Just so that if, say, because I know our copy machine's not the greatest, so this, like, see that little, I could see a kid going, I don't know, it kind of looks like a bubble. So if it's fog, like f of g of x, and it's composite, or g of f, but typically on your quizzes and tests, I'll write it this way so that you guys know it's a function substitution, okay? Okay, so FF is you're multiplying. So you're taking that 2x squared minus x, 2x squared minus x. So you guys could give that a try. You could either do arrows or repetitive multiplication. Or if you guys want to do your box. So I'll stop the video here if you guys want to just take like 5 minutes, give this a go, see what answer you get. And then if you're, well, maybe I'll wait longer. G of f of x means I'm putting the function f into g. So you're going to look at the g function, which is 3x squared plus 5. You're going to substitute into that x. All the calculators are over here. I moved them.
Why?
Because it was getting crowded, because in my other classes I have 8, and they usually plant their stuff there, and then it gets like squishy. Okay, so here then, g of f of x, you take the f function, but instead write 3x squared plus 5, 3x squared plus 5. Instead of x, there's my placeholder, I'm substituting the f in here. So you're going to put the 2x squared minus x there, right? And now you have to clean it up. And then here on the f of g of x, what's the f function? 2x squared minus x, right? 2x squared minus x. So wherever you have an x, you're going to be substituting. What am I going to substitute? The g function. And the g function is 3x squared plus 5. 3x squared plus 5. It's just instead of putting in a value, like a 4, -2, 0, whatever, you're substituting that. So some of them can be a little bit of work, and some of them can be a lot of work. So obviously you're going to have to FOIL this out. You're going to have to distribute either the box or the arrows where, you know, you do this. This one, you just distribute the negative. So I'll give you guys some time and then I'll do them.